Hello everyone, once again warm greetings to all of you. I'm your teacher Rahila Ehsan, and today we are going to start our new lecture number 4, which is related to chapter 5. And today we are going to study the electricity, the electric Ohm's law and resistance. So what is Ohm's law and what is resistance? Today we are going to discuss this in the chapter 5. So what is Ohm's law? Basically, Ohm, he was a scientist, and he presented the relationship between electric current and voltage. So he says that the rate of charge flow through a conductor is the strength of the electric current. So basically, we know that the rate of charge, we have discussed earlier that a rate of charge flow through a conductor is the strength of the electric current through it, and the cause of electric current through the conductor is the potential difference across its end. So the strength of electric current, the rate of charge, the flow, the rate of charge through any conductor is the strength of the electric current. And what causes this electric current? It is basically caused due to potential difference. So this potential difference, the strength of this electric current, they have a relation with the potential difference, or we can say that this potential difference is directly proportional to the electric current. So we can say that the more you provide the potential difference, the greater amount of current will flow inside the conductor. So this potential difference, it have a direct relation with that of the current. So in order to remove this proportionality sign, we usually place a constant, that is R. And what is R? R resistance. R is actually called resistance. And R is a constant, and this constant is the resistance of the conductor. We can find R is equal to V over I. And the unit for R is Ohm, named after the scientist who first introduced this concept. And 1 Ohm is equal to 1 volt per ampere, or we can say 1 volt per ampere. So what is electrical resistance? Basically, let's discuss through a simple diagram. Now, let's suppose that there is a pipe and water is moving inside the pipe. Okay, so inside the pipe, that for example, if we the pipe, the path of the pipe, this inside the pipe, if you place dust or stone, so definitely the stones inside the pipe will try to stop the flow of water moving across the pipe. In the same case, if you consider any conductor, any wire, like that of, if we consider them as a pipe, and the flow of electric current, we consider the flow of electric current as that of the flow of water, what will happen? That we know that inside the conductor atoms are present. Okay, so definitely when electric current is moving through the conductor, these electrons which are moving inside the conductor, they will definitely face collision. So they will face collision from the coming atoms which are present inside the conductor. So this collision will cause resistance. So definitely the electrons which are moving inside the conductor, they will face resistance. The atoms, they will oppose the flow of the electrons. So definitely the electrons, they will face resistance, and we call this as electrical resistance. So this solid conductor contains a large number of free electrons, and the drifting means the speed of these electrons, the providing speed of these electrons through the body of the conductor constitute the electric current. So you can see over here, this is a simple structure of the metal, and electrons are moving. So definitely during the movement of electrons, atoms are present, and these atoms, they will tend to stop the movement of electrons. So definitely this tend to stop the movement, this resistance to the flow of electron We call this as electrical resistance. So now while these free electrons drift through the conductor, they encounter collision. They encounter means they face collisions with the atoms of the conductor, and this gives rise to opposition in their free flow. So each electron will flow opposition in their flow. So this opposition to electric current through a conductor is called electrical resistance, and it is denoted by capital R. And the electrical resistance of conductor is measured in ohm. Okay. So now let's do some question related to the electrical resistance and related to Ohm's law. Question number 1 says that calculate the potential difference across a 10 ohm resistor carrying a current of 2 ampere. So the solution is that we have voltage of 2 ampere, resistance of 10 ohm. We need to find the current. The current is given, that is 2 ampere, and voltage we need to find. So according to Ohm's law, that voltage is the product of current and resistance. Putting the value in the equation and doing calculation, so definitely the voltage comes out to be 20 volt. Question number 2 is that what is the resistance of a lamp when a voltage of 20 volt across it causes the current of 4 ampere? So the voltage is 12 volt, a current is 4 ampere. So we need to find the resistance. So according to Ohm's law, V is equal to IR. So R, arranging the equation, the R is equal to V over I. Putting the value in the equation, 12 divided by 4, the value of resistance comes out to be 3 ohm. Question number 3, the potential difference across a 3 ohm resistor is 6 volt. What is the current flowing in ampere? So you need to find the current flowing in ampere. So definitely the given values are a resistance of 3 ohm, voltage is 6 volt, and current is unknown. So according to Ohm's law, V is equal to IR. So I is equal to V over R. Putting the value in the equation, we get the current to be 2 ampere. So I hope that you have understood the lesson. This lesson was very simple. Do study and do practice the questions. Stay happy and take care of yourself.